Okay guys, so when we deleting something from a heap, okay, you cannot delete any node you want, because remember this is a priority queue. The node that you want to delete is gonna be the node with the most priority. So if it's a min heap, okay, when you impose or implement deletion on it, you can't delete this, you can't delete that, you can't delete this, that, or that. You can only delete the root, and that's what I really like about a heap, because unlike the linked list, you could delete in the middle, you could delete at head, you could delete at tail, really it was a nuisance. In a heap, however, you can only delete on one position, which is the root. So yeah, that's it. Now there's two steps, okay, to deletion. One is actually deleting this 2, okay. So now 2 doesn't exist, okay. This is in terms of a min heap, okay. Step number 1 is deleting the root. I'm just going to write it down here, okay. You're going to del the root, okay. Then after deleting the root, actually it's a 3-step process, sorry. You're going to do this. You're going to take the this element, right, this node, okay, and replace it with the root. Not replace it, but like delete it from here, and you're gonna put it in the position of the root. So now 10 is here, okay, 10 is here, and 10 doesn't exist anymore here as the child of 8. 8 does not have any child now, okay, it does no longer have any child. So now that's what it is, okay. So you're gonna replace your bottommost, okay, your bottommost and your leftmost node with the root, and assume you have a tree looking like this, okay, and it looks like this. Now in this case, if you want to do deletion, you don't have the sorry, I have made a mistake. It's the bottommost and rightmost node that you want to replace with the root. So in this case, you can see that there is no like bottommost and rightmost. I mean, this guy doesn't have any child, so you know that once you insert, you're gonna insert here, right? You have to, I mean, the point is, once you inserting, you do it on the left, and then you move the way to the right. So in this case, when you delete, you're gonna start at the left, and I mean at the right, and you're gonna move to the left. So you're gonna take this node, you're gonna put it on top there. Then this is not gonna exist anymore here. Okay, so that's how it works. All right. By the way, so if you have maybe this like that, and you want to do deletion, you're gonna pop this off, and then you're gonna take this node and you're gonna put it over there. So yeah, interesting, isn't it? So now once 10 is there, you're gonna have to do the 10 step, the third step, because remember this is a min heap, but you have a 10 on top, and 10 isn't the main, or like the minimum number inside of the tree. So if you have a situation where this is a minimum number, then you can leave it as is, okay. Step 3 would be optional, but if it is not, then step 3 is compulsory, and step 3 is called heapify down. We're gonna heapify down. When you delete, you heapify down. When you insert, you heapify up. Okay, so how do you heapify down? Simple. You're gonna maintain the property. You're gonna see that you can, by the way, you can take it that way or you can take it that way, your choice. Okay, I'm gonna take it this way here. Okay, and I can see that 3 is actually smaller than 10, so I'm gonna now swap 3. I'm gonna put 3 on top. Okay, and I'm gonna put 10 there, and then I'm gonna see that actually okay, 3 is actually in the correct position because 3 is smaller than 8 and it's smaller than 10. So yeah, but now 10 is actually in the wrong position because 7 is actually smaller than that. So I'm going to swap this with the 7. So 10 is going to come here and 7 is going to come over there. Okay, so yeah, 10 is no longer there. So yeah, that's pretty much heapify down and insertion, or sorry, deletion. Now I want you to do the same. Basically what I want you to do is this. I want you, actually not that, I want you to take this tree and I want you to delete. Okay, and after implementing Heapify down or up, whatever it is, okay, I want you to convert the resulting tree to an array and then show me what the result is inside the comments, and if it's correct, I'll tell you it is. So yeah, thanks for watching.